Okay, good afternoon and welcome to CANI's webinar on Local Law 97. This is part of a series of webinars we've been hosting, looking at the how to respond to Local Law 97 and in particular in conjunction with FISP. Today, the focus is more on compliance with respect to glass and metal, particularly curtain wall buildings. So let me just move on the slides and we'll just give you a bit of an introduction. My name is Stephen Lythe, I'm the CEO for CANI, and I'll be introducing the panel shortly. CANI, when we were looking at this problem as it was developing, seeing Local Law 97 taking shape, recognized that both pieces of legislation, FISP Cycle 9 that looks at the integrity and safety of the facade, coupled with Local Law 97 that seeks to impose controls around levels of energy released, could be looked at together if you think about it thoughtfully and have a more strategic approach in terms of how to develop your building. So today we'll be looking at the aspects of the timeline. We'll look at what we typically address in an investigation, and both with respect to Local Law 97 and FISP. And we'll give you some examples of some case studies and what we see as the impact to owners. We've very much taken a view that we want best of breed in addressing this. CANI has deep expertise in the facade and roof windows and so on and so forth. And MG Engineering bring great expertise with respect to the mechanicals and overall energy assessment. So today the panel is made up of John Rudisill, Thomas Seminara from CANI, and Adam Farber. So gentlemen, perhaps you could just introduce yourself. John, I'll let you take over first.
Great. Thank you, Stephen. My name is John Rudisill. I'm a Senior Vice President here at CANI. I've been working with CANI for a little over 22 years now. My focus here has been primarily ground up new construction, as well as curtain wall, window technologies, glass and glazing, and more recently building redevelopment, which would include facade recladding and some deep energy upgrades to the building enclosure, as we're going to discuss today. And with me today is my colleague Thomas Seminara.
Hi, welcome. Thank you for joining us for our third installment of our webinar series here. John and I have worked together for the past 22 years. I've focused on existing buildings and FISP-related issues, and we are excited to bring this case study to you and hopefully shed some light and enlighten our colleagues about the problems and challenges with dealing with FISP and Local Law 97.
Hey all, I'm Adam Farber. I run the sustainability and commissioning group at MG Engineering. MG is a full-service MEP engineering firm based in New York City with offices in Florida and Long Island as well. At the sustainability group, we deal with all energy and sustainability related elements that buildings have to grapple with in today's climate, including Local Law 97, which of course is the energy compliance law in New York City.
Great. All right, well, let's move on and talk about, again, as Stephen mentioned earlier, we have Local Law 97, which is a relatively new piece of legislation. Everybody's pretty much familiar with that right now in terms of reducing carbon emissions by overall, I think it was 80%, Adam, by 2040. And the timeline for Local Law 97 coincides with FISP. Now, FISP is the legislation that everybody knows and loves. It's been around for about 40 years now. It's formally called Local Law 11, excuse me. So it's FISP stands for Facade Inspections and Safety Program. We are currently in the 9th cycle of FISP, and the deadline is 2024. So building owners need to make sure that any building greater than 6 stories, they need to make sure that their building enclosures are safe. They have to do repairs as required by 2024, and that coincides with the first deadline for Local Law 97. So in 2024, the building's performance will be recorded and it has to be reported by May of 2025. And that's when the assessment will tell you whether or not you're going to have some fines, because if you're over, for each metric ton that you're over the allowable carbon emissions limit, you have a $268 fine for each ton. So it can be pretty significant. So again, that's why there's a natural synergy between FISP and Local Law 97. You're mandated by law for FISP to perform repairs. If you have to do a multi-million-dollar campaign, you better make sure that your building is as thermally efficient as possible. It behoove you while you're out there, so that you can mitigate or eliminate potential fines in energy fines in Local Law 97 2024. So let's go into the next slide. We'll talk about our investigation and what the process is. So we're going to talk about a building, commercial office building today that we've been working on for the past couple of years, dealing with some challenges. And as Adam is aware, this building has both energy performance as well as facade challenges. So our process is basically to get out on the building and do an assessment. And we do a lot of assessments via rope access versus swing stage scaffolding. It allows us some flexibility in terms of investigation.
Yeah, this building is a great candidate for that. It's easy to rig. It's
multiple setbacks, so it was good to do by ropes.
Yeah, it's certainly cost effective to get out on ropes to do the inspection these days, because the increasingly stringent FISP requirements that now say we need to do a physical drop every 60 feet as opposed to a single scaffold drop in the past, is just reinforcing the fact that rope access is a great means to get access to the building, save our clients some money, and gather a tremendous amount of information from up-close inspections.
You can do a full assessment. So we'll do a hands-on physical investigation of the building. In conjunction with that, we're going to be looking at the building enclosure in terms of the facade and determining how thermally efficient or not it is. Our colleague here, Adam Farber, would be, while we're outside of the building performing an investigation, you would be inside the building looking at the systems.
Yeah, I'll be taking a look at, and my MG team will take a look at the building's mechanical systems primarily, as well as lighting and other energy using systems. But as we all know, most of the building's energy use comes from heating and cooling systems. And so we will spend a lot of time looking at those systems, looking at their efficiency, their performance, their operations, and their overall use within the building structure. One of the very important elements of looking at a commercial building like this is understanding who controls what system and who pays for what system. And those are really important elements of this investigation and today's webinar that we'll get into a little more.
All right, so let's take a look at the building, our one case study here. So today we're really focusing on a commercial office building versus a residential tower. And we're looking at curtain wall buildings, and the era of curtain wall that we're talking about are early generation. So this particular building was constructed in about 1958, basically a 30-story commercial office tower. And this is a very common curtain wall. This kind of curtain wall, the early generations came about in the mid-1950s, and they were ubiquitous up until about the late 1970s, when they started to introduce new technologies for thermal improvement facades.
One thing I may be just quick to point out, it's important to note that this building is a commercial building and it's being gauged on different guidelines.
In terms of energy
criteria,
use.
Right, energy use criteria. There are often these buildings now being converted to residential, and that would change the requirements or I should say the limits that it would apply.
Right. So the commercial office building, Adam, as you mentioned earlier, is this is tenant direct metered. So maybe you could speak to that versus a residential building, how the energy usage impacts the owners at the end of the day as well.
Yeah, so the big deal in this building, in these buildings, in a residential building, you might spend a lot more time looking at the equipment involved, because if you think about a residential building with, 150 residential units, every single apartment has its own heating and cooling system, and in some cases they'll have multiple. So you've got hundreds and hundreds of air conditioning, heating, and cooling units in a residential building. In a commercial building, you might have far fewer. You might have one per floor. We'll get into the specific equipment later on, but equipment tends to be less of an issue in a commercial building just because there's less of it, or it's an issue in different ways, which we'll also get into a little bit later on. The bigger issue that I do want to discuss now is the metering situation. So I mentioned a moment ago, very big deal is who controls what system and who pays for what system. And you'll find in a lot of commercial buildings that when a tenant takes out a 10 or 15 or 20-year lease, the tenant will have a direct meter through Con Ed. The building owner and manager will have no input and no knowledge really of the tenant's energy use. In some cases, very little knowledge of the tenant's energy use, and therefore really very little way to impact it. And that's a real problem for Local Law 97 because the building owner is still responsible for all energy use in the building. So we still have a couple of years until Local Law 97 takes effect. And one of the really urgent matters for a building owner or manager to take care of right now is to begin to get a handle on how much energy is being used in his building, what types of energy in terms of whether that energy use comes from steam, natural gas, electricity, etc., and where that energy is being used in the building. So you'll have some tenants that may have server farms in the building and are huge consumers of electricity, right? Because those things run all night, 24/7. They have to be cooled constantly. And that's a reasonable energy use. That's not something you can really penalize a tenant for being unreasonable if a tenant has a server farm that they need to maintain. Whereas another tenant might be sparsely populated and might have much lower heating and cooling loads. And therefore, that tenant's energy use is much lower. And a building owner or manager really needs to get a handle on that information because it's going to significantly impact how they will address the overall energy use in the building and how they will lower it when the time comes from Local Law 97 that they need to lower the energy use.
Right. So what we did on this building is basically establish a baseline through our investigation. As I said before, we were outside looking at this building, doing hands-on inspection. We modeled the performance of the existing curtain wall assembly. We actually performed air infiltration testing. It's very, very important, as Adam, you can attest to, that we need to understand how much air is infiltrating and exfiltrating this building, how many exchanges of air that you have, because that's how much heating and cooling, what the load is on your systems. We needed to understand those numbers. So we established a baseline. And at the end of the day, we determined the building was looking at some potential fines, and it has an ongoing FISP issue with this particular kind of curtain wall. So let's move on here, and we'll show you some other examples of the curtain wall type buildings that we're talking about. These two are examples of relatively early generation glass and aluminum buildings. The one on the left-hand side is actually adjacent to the United Nations Plaza. That was a 1963 curtain wall. At the time that it was built, it was the premier address in New York City. Interestingly enough, Johnny Carson bought the first penthouse in one of these towers on that building on the left-hand side. On the right-hand side is a late 1950s. It was constructed in late 1950s. Again, these glass, you can tell these curtain wall systems were basically the same manufacturer. Back then, it was only one or two manufacturers making these types of wall assemblies. So you see these kind of commercial office facades throughout New York City. This is a very, very ubiquitous type of wall system. On the next slide, we'll continue with some other examples. And again, the building on the left-hand side, that was a 1969. So again, we're approaching 1970s, but the technology hadn't changed since 1955.
Yeah, they basically look the same.
They basically look the same. It literally was the same manufacturers back then. Couples curtain wall was the most famous one, or the most ubiquitous one. But if you look at the photograph on the right, you can see what these curtain wall systems composed of. They're very, very thin. I mean, there wasn't a whole lot of mass to them. Those vertical, what they were called vertical mullions, that's the structure of the exterior wall. That's supporting the vision, the glass windows, and the metal panels that cover the spandrel areas.
What was nice about these at the time is they offered large vision areas,
Yes.
right? The vision lights, it was a huge change from the pre-war brick buildings where you had small windows and lots of massive of brick and wall area. Now you have these beautiful wide open windows and offering light and air, you know, which is
a good point. These were office buildings. So you had basically horizontal bands of vision glass. The problem is that glass is all single pane. The metal panel that you see is probably an 8-inch thick piece of aluminum.
Zero insulation.
No insulation. We'll show you some photos of what's behind that shortly. And those vertical mullions are extruded aluminum. And again, that's the structure of the wall, but that's also all outside. So that's acting as a gigantic thermal conductor. Right. You know, you're losing a lot of energy right there. You have all that mass on the outside, generating heat loss.
No thermal break from interior to exterior, right? There's nothing to stop that conduction of hot and cold from interior to exterior and vice versa.
Not at all. So if we go to the next slide, we'll show you some pictures of what, so here's the typical conditions as it relates to FISP. And here's what the problems are. Again, you've got 63, 65-year-old curtain walls. And the photo on the left-hand side, you can actually see towards the left-hand side, sealant falling out of the mullions, right? So once these systems start to lose the seals, the perimeter glazing gaskets, then things start to rattle around. Okay, but the glass is retained. This is a FISP problem because once the sealant fails, you get to storms with the high wind pressures. You're going to get things moving, and that's when glass breaks. And that's a big FISP issue. The DOB is really focusing hard on these types of buildings.
Yeah, and the deteriorated sealant. While it doesn't look that serious on, from the outside, like not that big of a deal, but this is the primary weather seal for the entire building. This is where all the air, all the water can penetrate the building through a single seal that we're relying on to keep air and water out.
They're essentially barrier systems.
Right. And the aluminum and the system as designed, there's a tremendous amount of movement thermally in these systems, which causes sealant failure exponentially.
Exactly. And so that's an ongoing problem. And there's only so many times that you can recaulk the facade. You're not going to get much greater performance. There's nothing you can do to improve these types of walls thermally. The only thing you can do is try to keep the air and water out. If you look at the next, we go on to the next slide here, we'll take a look at the inside of one of these buildings. This is what you're typically seeing from the inside. I mean, there's a fixed vision lights, and then they do have these small projectile awning operable vents. The building that we were investigating, you can clearly see that the aluminum has started to pit because of chronic water infiltration. You see how thin the system is. There's no thermal break there. It's all extruded aluminum, single pane lights. And again, you look at the photo on the left-hand side, at the bottom, at the base of all these windows, you have the perimeter radiators, right? There's a cover, and underneath that guy is a radiator. It's a steam radiator. It's a steam radiator. Which is a problem for these buildings because it's right on the perimeter of the envelope where there's no insulation. It certainly impacts the poor performance of the exterior wall. Certainly impacts the controllability of the steam, and the steam actually. We have condensation problems, right? Obviously, on particularly cold days, and you have a lot of air infiltration. That results in condensation developing on the interior surface of these walls. And particularly if you look at the next slide here, we're going to open up. So the photograph on the left-hand side, excuse me, you can see actual damage. There's staining coming from the top of that corner mullion, staining and discolorization. That's both because of leakage during rain events, but also a lot of condensation was occurring in this building. And you can look on the right-hand side, we actually took out some of those metal spandrel panels to see what's behind that. And what you see is, well, you see the backup wall. You see the CMU block backup wall. There was no insulation behind that curtain wall.
Right, so you have a concrete frame building here.
Well, this one was steel frame, concrete encased. Yep.
And then you have infill block.
Yeah, they do the CMU as a knee wall.
Right. Which inevitably, is not completely airtight and is a huge source of air infiltration beyond the window assembly itself.
Absolutely. I mean, once air gets behind the curtain wall, like you said, Thomas, that goes right into the knee wall, goes right to your radiators, which causes condensation problem. The water, once water infiltrates, these were not designed to drain really well. There is a flashing that was installed back in 1955. That metal flashing leaks like a sieve. All the seams have failed. All the lap seams have failed. So again, you've got massive amounts of air infiltration, water infiltration, and then once the cold air makes contact with the interior, we've got condensation problems. So we've got all kinds of issues to deal with here. If we go to the next photo, the next slide, this will show you a kind of diagrammatically what we're looking at. On the left is the actual snapshot of the shop drawings from this building's curtain wall system, the 1955 shop drawings. And as you can clearly see, it is just extruded aluminum. There's no thermal break from the outside to the inside. These were all constructed with single pane glass.
Relying on a single sealant joint to resist water and air infiltration.
Absolutely. Basically just barrier systems. But what we did find, which is encouraging for these types of walls, is if you look on the right-hand side, the photograph, these were the structural attachment of the wall to, from the exterior wall to the building structure was intact and actually surprisingly in very, very good shape. I mean, these curtain walls were anchored to the buildings using massively over-engineered steel anchor clips. They're embedded in the backup wall. I guess the good news about the air infiltration is that if water got behind the system, it would dry out pretty quickly. You know, you didn't because you know you had a lot of air movement there, so water wasn't allowed to sit on the structure very long and cause it to corrode. So you got good bones to deal with here.
Right.
If you're going to talk about, and we will, what to do with this, right? So this is what you're looking at behind most of these curtain walls. There's no insulation, backup walls that are not sealed, no waterproofing, no air moisture barrier like we do today, and that's where we're faced with these, the combined FISP problems and the energy problems. So if we go to the next slide, we're going to talk about briefly what can you do. And again, this is from alleviating the FISP, primarily the FISP issues, but we're also dealing with energy here. This was a building that was downtown on Water Street. It was also, this was like a 1972 office tower. Again, we're coming up to the end of the early generation. They didn't really start implementing thermal breaks until late 1970s. So a building like this, there's a couple of different options of what you could do. A lot of, right off the bat, owners think, my God, I have to tear off this wall and put a new skin on the building. That obviously is very, very expensive, and that has a massive amount of tenant disruption. Some towers like this opted to do kind of a hybrid of that, where they replaced the windows first, from the inside. Contractors went in and took out the existing vision glass and optical vents and put new ones in. And then on the outside, they clad over the existing spandrel panels with new spandrel glass. You can mechanically attach spandrel, so you're cladding over it. You're not getting a whole lot of insulation value out of that, a little bit. The windows is where you're really getting the high performance in terms of thermal break, new insulated glass. And the spandrel panels, they simply covered it, sealed it, and encapsulated the original spandrel. So it's a cost effective. It's kind of the, it's much more cost effective than tearing off a wall. And you get some improvements in terms of your window. And that also gets the energy. That's a big deal. If you replace the windows in and of itself, that's cutting the air infiltration down massively.
And technology with insulation is improving every year, right? There are vacuum insulated panels that can be installed these days that have much more high insulation values than previously, available products.
Right.
So even I would imagine in the next few years, there's going to be even increased, available products that we can implement into systems like this that will increase the R and U values that we would like to see.
Absolutely.
Hey, John,
yes.
If we could just pause. I've got a couple of questions. One, I just wanted to throw out there, and I would certainly say to all of the people on the call, if you've got questions, please put them in the chat. We'll make sure we address them. This question really relates to if there's any opportunities for buildings where they're housing TV production, particularly live shows daily. Do we see any scenario in which there would be changes in the emission limit requirements for these type of facilities, because they have very significant cooling demands around the clock? it's basically not a regular office building, but presumably they still have to conform. Adam, do you have any insight on that?
Yeah, I can speak to that very quickly. So there are a number, the city has published a number of potential reasons that a building could file for a deferral on Local Law 97 or an extension on the Local Law 97. And one of those reasons is 24-hour use. So they understand that a typical office building might be in operation, let's say 9 to 5 or 8 to 6 or something like that. And many office buildings are 24-hour, as be with the case here, that a building is in operation overnight and may have active use throughout the night and therefore has a much higher heating and cooling load during those times. The building's department has said that 24-hour use is a potential reason for a deferral on your Local Law 97 obligations. The problem with that is that you would have to submit an application for deferral, and that application is due very soon. It's actually due next week. So what I would recommend at this point is the specific case of this building that has live shows going on every day. First of all, I want to know where it is because I kind of want to see a live show now. It's been too long. And the second point is I would encourage you to reach out to us, and we'll see what we can do in terms of helping get that deferral. But at this point, it's going to be difficult to slot in there. Although if we work, we could try to find a way.
Thanks, Adam.
Yeah. Great. So let's go into the next slide here. We're going to talk about another upgrade option that that building owners can opt for. And this is actually a really, we think is actually probably one of the better options. It's a fully unitized approach to recladding a building. As you can see on the photograph on the right-hand side, various manufacturers will essentially just fabricate a large window that incorporates your vision as well as your spandrel area. It's a thermally broken, it's basically a new thermally broken curtain wall system designed to be retrofit onto an existing a curtain wall. Again, like we talked about.
So in these instances, they attach basically right to the structural mullions.
Right, because like I said before, those vertical mullions are the structure for the exterior wall. They're typically, the anchors are in great shape, even though it's been 60 years. So there's really no sense in ripping off or demoing the existing wall. On this particular building, it worked out very, very well because there was no disruption to the tenants. During the day, the contractor was on the outside of the building. As you can see, they're attaching this new curtain wall to the existing. The existing windows remain in place. And then in the evenings, when the office is vacant at night, the contractor would come in, take the original vision glass, the original windows out, and install trim and paint and new interior finishes to meet up.
All from the interior.
All from the interior. Now this option works great because before they put that big unitized panel on, as you can see, you can look behind that, we were actually adding about 3 inches of insulation to the spandrel areas. And so you get a massive amount of insulation added to the building, in addition to that new curtain wall frame had insulated glass. The glass in the spandrel area was all, as well as IGUs, all insulated units. So you're getting a huge, huge thermal upgrade. You're also encapsulating all the problems that you had with FISP. That all goes away. This is a brand new system.
One thing that we didn't even touch on, which is often a problem with this, is that when you're even resealing these older buildings, you run into ACM issues.
Asbestos,
Asbestos in the ceiling.
Yes.
And you have to encapsulate that, or you have to contain it and dispose of it. That can add tremendous amount of money to do a sealant replacement job on an old building that you're really not getting any value from. So we've been really successful in recladding it with this option. We've done these in fully occupied office buildings, in hospitals, outside operating rooms that are ongoing, fully serviced, and no disruption in the tenants.
Well, that's it. They got to keep these buildings occupied and operational. And it's just a huge, huge cost if you have to disrupt a tenant. So again, to Thomas's point, we're avoiding some huge abatement. I mean, this particular building was about 180,000 square feet, and it was $1 million number, over $1 million for the abatement alone. the air monitoring and the abatement, plus the tenant disruption would have been huge. So we solved a lot of problems, and clearly on the mechanical side, you're taking your air infiltration. It was on this building we measured, it was 20 times over the allowable if you were going to use the current New York City Energy Code as a benchmark. So we basically have a new skin on the building, significantly reduces air infiltration. Those new insulated spandrel panels are going to protect the radiators that are right behind it. If we go to the next photograph, the next slide, you can see that once you have those brand new windows in, you don't have those 1955 ugly awnings all over the place. It's just a nice big vision light, lots of light back into the office. And again, around the perimeter, all those radiators are now protected. Condensation issues go away.
And again, it goes without saying, but like the glass that you're installing, this is like modern glass, even though it's an insulated unit, it's lowly coated as, it could be, argon filled.
Yeah.
All types of contemporary attributes to the modern glass assemblies that reduce the solar heat gain.
Yes.
In addition to air infiltration, but just the comfort level that's attained by coatings alone is a huge upgrade for these spaces.
Absolutely. Absolutely. And you can see on the right-hand side, they're just about finishing up. It does transform the look of the building. I mean, architecturally, you're not going to change it significantly when you're doing a reclad, but it's going to look new. It's going to be high performing, a heck of a lot nicer than what it did look like.
Right, and cheaper to operate for your tenant. So your marketability goes up for a tenant coming in to lease a space and realizing that they have a new modern system that's going to keep their energy cost and usage down.
Right.
So
let's dive into that in terms of the mechanicals. So Adam, we can move on to the other. So we talked about previously residential buildings. Our last webinar was about residential apartment tower. So mechanically, here we are with a commercial office building. Let's talk about that. What are we going to do?
Yeah, so Tom was just talking about the tenants, the marketability for the tenants and tenant comfort and so forth. And obviously now we get into the mechanical systems, and something that I mentioned earlier is one of the very big deals in a commercial building is the controllability of systems and who's paying for the systems, right? And so I don't have as many photos as the Canny team does. Their photos are they come from outside and there's beautiful sunshine. My photos are in a mechanical room or in a basement somewhere. And so I tend not to use as many photos, but the concepts that I'm dealing with are actually relatively straightforward, right? So on the left-hand side, we're looking at a tenant-side water source heat pump. So this is a cooling unit, a heating and cooling unit installed either by the building on behalf of the tenant or by the tenant. Depending on the building. Different buildings will have different standards. But regardless, this is going to be a unit that is almost always controlled by the tenant and usually paid for by the tenant, meaning the operation of the system. The ongoing operations will be paid for by the tenant. And that's a really big deal because a majority of the heating and cooling power comes from this system right here. In many of these buildings, and the owner doesn't really have access to that bill. So that becomes a very big local law 97 issue. On the right-hand side, you'll see the cooling tower. The cooling tower is essentially always operated by the owner. There may be a few smaller cooling towers on setbacks or throughout the building that are operated or managed by specific tenants. And those will fall under that first issue that I mentioned, but the owner is paying for the operation of the cooling tower. If there's a base building chiller, the owner is going to be paying for that as well. That's obviously a huge energy suck and an energy user that a building really has to account for. The perimeter heating, which we talked about before, with the perimeter radiators, that will also generally be paid for by the owner. If it comes under a Con Ed steam bill, or if steam is being created in the building by a natural gas or even worse, an oil boiler, those are going to be paid for by the owner. So the owner may have the payment responsibility, but may not have the control of the system. In many cases, especially in these older buildings, the control of the system often just doesn't exist. right? If you're dealing with buildings that are on original building chillers, or let's say the chillers were replaced in the 70s or 80s, so now you're dealing with 30 to 40-year chillers in many cases. Those chillers don't have a turn down ratio that can really accomplish a single floor's cooling, or cooling of a single area in the building. And so in many cases, you'll have to run heating and cooling for multiple floors, even if there's only one tenant who's looking for after hours cooling. And that is a real waste of energy. And it's something that buildings have to account for. So you've got these two twin issues that these buildings—
they're gonna pass on that cost to the tenants, right? So it's not that they're just gonna eat it and say, oh, I got an old style system, there's nothing I can do. Right, this is gonna increase your rents, increase your assessments, or other things that will negatively affect the marketability of your space.
Absolutely, absolutely. So you've got these two twin issues that a building really has to deal with, that a commercial building really has to look at. The first issue is their own systems, which are in many cases very old. Not always, but in many cases, you're dealing with original building chillers, cooling towers, boiler plants. The water source heat pumps may be much newer, because as a new tenant comes in, those spaces are often going to be fit out. So that really taps into your second issue, which is your controllability and your payment of systems. And the owner is going to have to account for that, because he may not be paying the utility bill, but he will be responsible for the local law 97 fine. And
Right.
So that's something that an owner definitely has to address, as we're going to get into in a moment.
Yeah. So let's go to the next slide here. So this particular building, when we completed our combined assessment, Local Law 97 and FISP, what we found is that there were a number of brand new tenants in this building, so they did fit outs. So from Local Law 97 perspective, we didn't have a fine. They are not subjected, they will not be subjected to a fine in 2024. They do have a FISP problem though. And
which will amount to basically resealing.
Well, exactly.
The entire building.
So it's a pretty significant cost. Again, for this particular building, is about 180,000 square feet of it. So we took a long view here. We did determine though, based upon the configuration of the mechanical systems today, that they would have a penalty in 2030, because the allowable carbon emissions limits get cut by almost 50% between 2024 and 2030. And then, at 2035 and 2040, they keep getting cut again and again, each cycle about 40%. So we knew that we've got problems. You've got a FISP problem today. Presumably, if you don't change your wall system, you're going to have a FISP problem in cycle 10 in 2030, and then 2035, it goes on. And then the energy fines will start in 2030. So we're giving the owner basically a phased approach here. If we go to the next slide, what we ended up coming up with a plan for is in 2024, or by 2024, we're going to do some localized repairs, which is, we're not going to replace 100% of all the buildings' perimeter seals. We're going to deal with areas that are deteriorated now, do a localized approach. Do a localized approach with the optical vents to kind of tighten those guys up a little bit as much as we can. Basically make the building safe, in terms of FISP. And then plan for a major campaign in 2030 where, we're going to do a facade recladding. We're going to take that approach here because, again, the FISP issues will be reoccurring year after year if you don't do anything. Now, on the operations side, on the mechanical side, they're going to continue, and you can speak to this, Adam. They're going to continue with, they already did implement visa new tenants, some energy conservation measures. We have a lot of new thermally efficient equipment, but what other, I'm going to call it the low hanging fruit, but what other energy conservation measures will they be implementing in 2024 and then on the way to 2030?
Yeah, so the big measures that we looked at in this building were, there were really three big measures that we looked at in this particular building. We looked at lighting. Lighting is super low hanging fruit for buildings. The concern is tenant spaces, of course. When you have a lot of tenant spaces that may be older and have not upgraded their lighting. And until Local Law 97, building ownership didn't care because they weren't paying the bill and there was no impetus for them to get involved in that. Now there is impetus, And so while base building and back of house and common space lighting has mostly been upgraded throughout the city, tenant space lighting is now the next frontier.
Right, because you've got some tenants that have, in this building, 4 or 5 floors. They could have 75,000 square feet.
Absolutely. Absolutely. So that's the first piece of low-hanging fruit. The second piece of low-hanging fruit, you may have noticed the difference in the 2 slides, is the use of number 2 oil. So you'll see on this slide here that number 2 oil is listed, but there is no energy use. And that's because we recommended that they get away from that. So for Local Law 97, also, by the way, for paying utility bills, number 2 oil is the most expensive and least environmentally friendly fuel that is commonly available today. Whenever we see buildings that are operating on oil boilers, we always try, if it's feasible, if it's constructible, to get away from that system, because it's, first of all, oil is the most expensive fuel, the most expensive heating fuel out there for the buck. And second of all, it is very heavily penalized for Local Law 97 for a number of reasons. So we worked on converting the boiler, and actually in this particular building, it wasn't even the entire boiler, it was just the burner, swapping it out for a natural gas burner. The building had already had a natural gas service because the restaurant was on natural gas for their commercial kitchens. And so it was a less expensive upgrade than it might have otherwise been. Natural gas was already available. And so we didn't have to impact the entire perimeter heating loop at all, because the steam conversion was downstream of the entire heating element. So we really just had to work in the boiler room. And the proposal was to swap out this building, get them off of oil and get them onto natural gas. The third big upgrade that we made in the building was pitching controllability of systems. So this building, as with most buildings, doesn't have a central building BMS. They don't have a centralized way for the owner to be aware of energy use throughout the building, and certainly not to control energy use throughout the building. And so we encourage the owner to get on a BMS, or a building management system, which is really just a software-based system of allowing knowledge and potentially control of heating and cooling, lighting if there is, ventilation, and other systems throughout the building. And the advantage of this is that, for example, in a tenant that leaves their cooling on overnight, even though nobody's there, because the tenant isn't super involved in that side of the operations, the owner can now, with the tenant's permission, the owner can now get involved and help the tenant lower their own utility bills and help the owner lower his Local Law 97 obligation. By the owner having awareness and potentially control over some aspect of the tenant systems. Obviously, that's something that would happen with the tenant's permission and with the tenant's input, but that is definitely something that we pitch in a building like this, because when you're dealing with long-term tenants on extended leases, then the tenant does want to be a good partner in the building, and so they're generally involved in helping the building figure these solutions out.
That's interesting. Yeah, you got to get the tenant buy-in for that, which is a pretty easy sell if you're staring down massive fines every 5 years. Or actually, the fines, the fines are every single year.
Fines are every year.
So if you have a fine in 2024, you're going to pay that fine in 24, 25, all the way up until the next cycle when the limits get cut even more. So the cooperation between the tenant and the building owner is really, really important. And so in this particular case, by 2030, the plan is to continue with the mechanical systems and the operations, the energy conservation measures, but then by 2030 to have a new, they're going to go down the unitized cladding approach, because they can keep the building fully operational. There won't be any tenant disruptions. And so once you get to 2030, what other, looking further downstream in terms of Local Law 97 for 2035 and 2040, what else can you do? I mean, it's the big ticket items, I assume, are your cooling towers and your chillers. If you've got 40-year-old chillers and cooling towers, what are some options?
So there are other options in terms of equipment, in terms of equipment controls, but really the biggest option, and this is the reason that we have Canning and MGE working together. Very frequently, a big thing that the building has to look at is the envelope.
Yeah.
which buildings don't want to look at because, as John and Tom have done a great job of explaining, it's expensive. And it can be a headache to make significant envelope upgrades. John and Tom have done a good job of explaining ways that it's not potentially such a headache, and making those upgrades really will be crucial ultimately to the building's energy usage in terms of cutting down air infiltration, which is a huge waste of energy in a building, and in terms of improving the envelope's thermal performance. Right, in many of these buildings, they explain there's no insulation in the mullions. There's no insulation between the windows in these thermal, I call them thermal breaks, but they're not thermal breaks, they're thermal bridges really. And the windows themselves are not very thermally efficient. They're single pane or perhaps double pane glass, but they're older windows, they're not well air sealed, they're certainly not well thermally sealed. And that's the biggest thing that a building's gonna have to look at down the line.
Yeah, well, all these materials that we deal with on a regular basis in this industry have a particular life cycle, right? Whether it's mortar, it's brick, it's sealant, these walls are at their end of their life cycle. And, ownership has to understand that you can't put a Band-Aid on this any longer, and it needs to be upgraded, and the overall benefit to the building, to the owners, to the tenants, and to the city itself is inevitable, and, will actually provide a return on their investment in years to come. There's, energy savings, there's marketability, there's increased, rent available when you have a Class A facade as opposed to an aging curtain wall facade. When you look down 6th Avenue in the 50s and your options are 5 buildings that were, designed in 1950, or this new building has got a nice new glass and, curtain wall on it, and you're looking for office space, which one is more attractive? Certainly an easy sell in that market. So there are a lot of facets to the benefit of this, aside from the intrinsic cost savings of penalties, but the environmental issue, the owner return on investment, all these things are I think owners are going to start to realize are increasingly important, and it'll benefit them in the long run.
Well, you have to put your energy rating in the lobby now, right? Or you have to post.
Sure. They're all posted now.
You don't want to have a Class A office building with a D rating on energy, and by the way, you don't want to have a Class A building with an unsafe sign in the lobby whereas the FISP. So. To your point, the life cycle. I mean, these types of curtain walls are basically at the end of their serviceable life. It's like a 50-year-old brick masonry cavity wall where the wall ties are corroded now. I mean, these things aren't not going to last 100 years. But the materials and the technology that we have today, I hope that once we reclad this particular building, I'm not going to look at it again until way after I retire. These will get you 40, 50 plus year life cycles easily now, so it's just time. And the good news is that you can do a phased strategic approach. We find that by coupling the building envelope with the mechanical systems and really developing a long-term master plan for the owners, there's ways to do this.
Right, like this is a really good example, because like I said, 2024 there's no big outlay of cash that they're in for. Now they realistically have 9 years to plan and to budget to do this and to execute this. This is the perfect example of what we should be doing now for our clients, to say that, listen, you don't have to do everything tomorrow.
Right.
But you have to plan for it, you have to budget for it. It's best to have the information at hand and to be able to plan accordingly for the future.
Right. Right. And
there's also now just released in the first building, I think got approved for the PACE financing, right?
Yeah.
Which, we'll have a further webinar on at some time in the future.
Yeah, we do have some partners that specialize in the PACE financing. It's a big deal. We'll just mention it. The first PACE deal
for New York City.
In New York City came through last week, I believe. It was also the nation's largest $89 million deal to do some deep energy retrofits in the building envelope and mechanical systems of that building down on Wall Street. So that PACE financing, again, to Tom's point, that's a separate. We do have partners that'll provide a webinar really geared toward PACE financing, as well as other new federal, state grants.
Yeah, like certain
grants.
incentives.
So there's a lot
Yes.
of creative ways to finance these huge capital expenses. So that's it. So I think that's what we've got for today. That wraps up our presentation. Let's see if we have any questions. Stephen, do we have any questions?
There are no questions out there at the moment. If anybody has a question, they can put it in the chat very quickly.
Interesting.
So I'm seeing none come through, but what I can tell you is we do record the session and we'll make that available to you. If you have questions that come to you afterwards, please feel free to reach out to us and we'll be quick to address that. If you don't have the emails for John or Thomas or Adam, simply reach us at info@canny.com and that will get us to us and we can respond accordingly. Otherwise, I'd like to thank Adam, John, and Thomas for their insights today, and encourage you all to reach out to us if you have questions. Certainly, there was one that was of the nature of some urgency, so we'll be happy to respond to that. And look out for future webinars, particularly around the financing component and other facets in this industry. Thank you very much, everyone, and thank you.
Thank you, everyone.
John and Adam.
Thanks, have a great day.
Thank you.
Thanks.